As a mobile developer, I built for the world's biggest platforms where millions of users connect, work, and play. Working on mobile involves repetitive, error-prone tasks that nobody in our team likes doing. Bitrise changed all that. It's CI/CD, built for mobile, Xcode, Fastlane, Android Studio, Flutter. It's all handled with hundreds of existing integrations, so I can build, analyze, test, and deploy my apps to the app stores. Thanks to Bitrise, I'm able to spend time doing what I love, building better apps, faster.
Great. So, hi everyone. Actually, at the beginning, I will tell you a fun fact. So I was asking one of my colleagues, he's Italian, and I was asking him, please teach me any word so I can say it in the presentation. I was asking about good afternoon, and he told me a difficult word, to be honest. So I said, you can say buonasera. So, buonasera. My name is Moataz Nabil. I'm working as a developer advocate at Bitrise, and today I will be talking about Barrel, or parallelization for testing, for Android UI testing. So previously, I worked before, so I started my career as a software engineer, and I worked with different business domains like agriculture, telecom, healthcare, and food delivery. And then I switched to be a test engineer and software engineer in test, and participated in different like test frameworks for Android, for iOS, for API, and websites as well. But currently, I'm focusing on implementing CI/CD pipelines to help mobile developers to accelerate their builds and speed up the release process and to like release apps to the market as like quickly or like efficiently as well. So, UI testing is challenging. So, are you agree with me? So, especially for mobile, because you have different challenges. It's not like a website. You have a browser and you can click on different elements. But web testing for mobile, it's required. You have a device. You need to install the application. You need to access maybe permissions or anything inside the device itself to be able to run your UI test. But here also we have a different challenge. So let's say, or let's assume that we already have a UI test inside our company or in our team, but we are scaling or our business is growing. So let's say we are working with enterprise application, and every week or every 2 weeks we are adding more feature. And this feature is required to be delivered. We should have at least 1 or 2 or 5 UI tests to make sure that the UI test or the feature is integrated correctly inside our application. So the first challenge is the business is growing. So maybe we can start, or we start with maybe 10 test cases or 20. Now we are growing now, our business is growing, the team is growing as well. We are scaling our engineering team and become a larger engineering team. This is another challenge. So how we can handle the process, or how we can run the UI tests on different stages, on every BR, or maybe a nightly build, maybe before the release or after the release. How can we manage this process with a larger engineering team? And at the end, we have hundreds of UI tests because like with each feature we are adding, so we are increasing the number of UI tests. So in this case also, we should select the suitable UI tests and when we should run these UI tests. For example, we have a scope for every BR or every pull request. We have a scope for nightly build, and we have a scope for before release, for example. And this also is affecting our build time. In case we are using a CI/CD server or CI server, continuous integration server, if we wanted to run 100 of UI tests, this will take time for sure. And also we have another issue that sometimes we have a flaky UI test, which is required to like rerun the UI test or rerun the build again. So now, and for sure, if it's affecting the CI build, this will affect our budget, for example. So if we are maybe if you are using a CI server like pay as you go or every minute, so now the build is taking a long time. So now we need to figure out how we can fix all of these challenges. Our goal is we need to accelerate Android app releases by reducing any test bottlenecks. So this is our goal, or this is our target from this presentation. So now let's get started. So at the beginning, why UI test or the automated UI test, or why automation is important for UI test. Writing UI tests are not just like a nice to have feature nowadays. So I worked before in one company, and like the code base, it was an enterprise company and a food delivery application, and we had one code base. We are like releasing 4 apps from one code base. So we have 4 variants, and we are releasing 4 apps in different countries with different languages, with different configurations, and so on. And when I joined the company, the target or the goal was we need to like rely on a test automation before releasing. So test automation will be our like the confident, or like this will be our check. Do we need to, or can we release our application or not? Or if there is any problem, if there is any critical test cases, we are not or is failing usually, so we need to fix it. So UI test now is not nice to have. And actually, one of the goals at this company was that the Android developers also should write UI test. It was not a responsibility for QA engineers or test engineers only, but also it was like a shared responsibility between the mobile engineers team and the quality engineers. And even as we mentioned, so the complexity of technology is growing, and also our business, complexity of the business. And we need to find the solution to optimize the cost. So test automation, if it's applied correctly, it will help us in 3 things. It will be it should be reliable, it should be robust and high quality, and it drives us to the cost optimization. If we are implemented it in like wrong way or without process, without test strategy, this will not be like cost optimized. Maybe this will take time more than the manual testing. In order to improve the app quality, test early and fail quickly before releasing the app. So there is a concept here, it's called fail fast. So let's imagine that when you are running a UI test and the UI test is failing in the BR. So one developer is create a change and he just commit the change, and the BR or the CI server triggered automatically. Now we are building the application, run the unit test, maybe run the static analysis test or static analysis for our code base, for code format and the length and everything. And we are running the UI test. And then we found the issue in the UI test. So the build now failed and the BR not merged. So here it's like a gate. So now we are stopped this BR from merging it to the code base or the main branch. So now we figure out that we have a problem. So we will start to investigate about why this test is failing. So we will find maybe we have an issue in the API, maybe it's in a UI, maybe it's in a UI test itself. So this is fail fast. So we are failing in the early stages of the development. So let's assume that we don't have a UI test and we already measured this code, we deployed or release it to the App Store, and we found or we find this issue in the live or the production application. So we can imagine that now we need to know the root cause because we don't know why it's failing and it's in production already and the customer already know about this issue. So because of that, test early and fail quickly, this is a principle here, or the type of failing quickly, and we will fix the issue and then we will fix it and run the UI test again. This is actually called shift left in testing. So we are moving testing from right to left. So previously we were testing on the production, but now we are moving it to left in early stages of the development stages. So in every BR, maybe a nightly build, so we just check that the BR or the code is working correctly. But the problem here also, so let's assume that we have already UI test, we have automated UI test, but the problem always is the scalability of running a multiple test in parallel. Why? Because you can imagine if you have a 100 test case and you wanted to run it in every pull request, so this will take or consume a lot of time. And why? Because if you have a one emulator, so you will run in sequential mode. So we will run all the 100 test cases in one device, and maybe we have a multiple flakiness or multiple flaky test cases. So the scalability or the issue here in the running in parallel test. So the execution best practice for Android UI test, we have 3 things. First one, we recommend to use a cloud devices. You can find a lot of cloud providers or cloud devices on cloud, like Browser Stack, Testing Boot, Sauce Labs, for example, or Firebase Test Lab. This is from Google. So you can use one of the cloud devices. Why? Because it's more reliable or more stable, and don't use like your in-house devices, because maybe if you are using like a connected device with your in-house solution, this maybe have an issue, so you need to ask the DevOps or the IT, maybe you need to fix it. But cloud devices are always up running, and you can run immediately on the devices. Run automated tests in parallel, which will save time and will save cost as well from your CI server. And using a CI/CD pipeline. So now we need to inject, or we need to add the UI tests as a layer inside the CI/CD pipeline to run it in every pull request or in every, like nightly build before releases and so on. Now the question is how to scale up the Android UI test. So here we have 2 different options I will be talking about today. The first option is a Firebase Test Lab and Flank. Firebase Test Lab is a cloud testing service from Firebase from Google, and we will use like a library. It's called Flank, and this is for parallelization, and this is only for Firebase. And the second option, we will use the Gradle parallel options, which is the test charts. But this is we can use it in like local devices, but in the CI server as well. What is Firebase Test Lab? It's a cloud-based app testing infrastructure to let you to test your application. It's supporting Android, iOS, and also you can use a virtual and physical devices on cloud. You can run tests on like wide range. You can run like whatever you have a number of test cases, and on real and real devices and the virtual device as well. And it's integrated with a Firebase console and Android Studio and the GC Cloud CLI. But how we can executing? So there is another problem. So because the idea here also with a Firebase Test Lab that you are running is sequential as well. Because if you are run in one device, you will run all the test cases in order or sequential, which will not save time. But the problem now, or the idea now, we will use Flank. Flank is a library or utility to be able to split up or like divide the test suites into small batches, and each batch will run on separate or a single device. It's an open source project, and it's developed by Walmart Lab, and you can find it for sure on GitHub. So Flank is a YAML configuration file. So previously, if you wanted to use, so it's based on a GC Cloud, and for example, if you wanted to run a UI test for Android application, you can use a GC Cloud Firebase test Android run. This is after you configured your GC Cloud application and you add the project name in the environment variables and everything. So the command is a Firebase or GC Cloud Firebase test Android run. But you will find that you need to use most of these annotations or like parameters or arguments to be able to run UI tests. For example, you need to add the device, you need to add the app, the test APK, the app package, the device name, the OS version, the result for directory, and everything. Number of flaky test attempt if you wanted to like retry the failing test cases, and so on. The orientation of the device, the OS ID, the page size, and everything here. So this is mainly how to use the GC Cloud Firebase. But with Flank, it's a YAML file. It's just you can create a configuration file, and under the configuration file, you can add all the things that here in the argument side. So for example, you can have 2 sections. One is a GC Cloud, and then you can have, after that, inside these things, you can have, for example, this is the result bucket. The idea here also about Flank that they are adding is a test result in the bucket on a GC Cloud. So you can have a test result in a folder for each build you are running. So you will find the test reports, the video for the UI test. You can find the lookat as well from the device, so you can investigate more about your test cases. And then, for example, you can add the environment variable. You can use orchestrator for Android X testing. This is the application. This is the timeout and test to target. Also, you can specifying which target or which annotation or which package you wanted to run in this test. And here on the device, you can specify the module and the version. And with Flank, they have a specific properties. For example, the max test charts. This is the idea. So here, when I'm saying max test charts, that means that I wanted to run 3 devices at the same time. So now, Flank, if, for example, if I have 30 test cases, and here I'm configuring that I wanted to run on 3 charts, this will split the test suite to 3 batches. Each batch will include 10 test cases. And here, for the test run or number of test runs, so I wanted to run them only one time. And this is the smart Flank GC path, which is the XML file added in the bucket to check for the next run if there is already a result for the previous run or not, because I don't want it to run it again. This is the smart Flank. So here in the GC Cloud or in the Flank configuration file, you have 2 sections. GC Cloud, this is for GC Cloud itself. It's mapped to the GC Cloud Firebase run. And under the Flank, this is properties or argument for Flank itself. Why sharding? So previously or without Flank, if you are running normally on cloud device, as we recommended that we need to run UI tests on cloud device, previously you can run as a sim. For example, you have test suite, you have 5 test cases, maybe this will take 25 minutes. But now with Flank, you can split your test cases 2 or like 2 in one device or 3 in one device. If you have 5, if you have 6, 3 and 3 and so on. And this will run on the same device, so it will, if we go back, it will run on 2 devices, Pixel 2 devices with version 28. And this will be run on 2 different devices, and then this will for sure eliminate or reduce the runtime. For example, how we can integrate this in the CI process or in the CI workflow. So let's assume that we are using Bitrise as a CI/CD platform. So once the developer is pushing the code, then the webhook will start Bitrise as a CI, or you can use your CI server. You can download, but with Flank, as I mentioned, you should configure the GC Cloud ID and the project ID to be able to send your APKs to the Firebase projects. So now I need to download the Google Service account, and I need to save it and add it in the environment variable inside my application, or inside my environment, inside my machine. And then I will build the application for this. So this also supporting Espresso or supporting the native testing tool from Android. So Android Build for UI test is giving me 2 APK. The APK itself, the application under test, or the APK, and the test APK. Then with Flank, I will start adding the configuration file, the YAML file, and then I will run the command line with Flank. So Flank will take my application and run on the Firebase. And then I need to pull the artifacts from the GC Cloud, from the bucket, and then send it again to the CI server. So let's have a quick demo about like Firebase. So for example here, this is the Bitrise, this is the Android, or this is the platform for a CI/CD. So here we have, this is a project. I have Android UI test, and this is my Android project. So for example here, I have end-to-end package, I have regression test, and I have a smoke test. For example, I'm dividing my test cases in 3 categories. And also I have a custom annotations. Why? Because I need to run the specific target or a specific group in every pull request. For example, the regression scope will be in every pull request. End-to-end can be on nightly build. Maybe I can run all of them like nightly or before release, just to make sure that all test cases are passing. And also inside the build Gradle file, here I'm adding the Android runner. I have a clear package data because this will be like running on different devices, so I need every time to clear the package data. And if I go to the workflow, this is a workflow editor. So here from here you can build your pipeline, or you can build your workflow, and then you can run it. So for example here, on Firebase, so I have a step for SSH key to cloning the code repository. I'm downloading the GC Cloud, and I can edit also the credential in the secret environment variables, and I get clone and installing the missing Android SDKs, and then building the application for UI test. Here you can find that I have two output variables. I have the APK path and the test APK, because I'm using Espresso as the test framework. So here I'm using Espresso. It's a simple application. Here I'm using Espresso. This is the first test function, and with the annotation as well. So test APK. And then here I'm generating the Flank file on fly. Why I'm doing this? So for example, you can save a Flank YAML file on your code repository, but this is just to configure it or to change it on live, and you can save it as well. So from here, I'm creating the Flank file. I'm creating the result. So I already should have a GC Cloud bucket, so because that I already prepared here. So in a Google and cloud storage, I have already a bucket called UI test, which will include all the build from my CI server. And then I am mentioning that the application, you will take it from the previous step, from the environment variable, which is the Bitrise APK. And this is the build number, so the result directory inside the bucket will be the name of the run. For example, it will be 50, it will be 12, and so on. And also you can save it in the card. You can annotate or run the annotation. For example, I am running the annotation with a regression test cases. And then with Flank, so here I am downloading Flank. So here I'm getting the jar file, because it's based on its Java application. And then I'm just running Android run, and just it. So once I'm running the UI test, so let's trigger one build. I can start from here. I'm selecting the branch that I want to run the UI test against, and then from here I can select the workflow, run a UI test with Flank, and then I will start the build. I will show you like a previous successful build, but this is the CI, or this is the build that I triggered. I triggered it manually, but for sure it can be triggered based on the pull request or tag or code push or anything. So now I'm start the build. So now let's check a previous one. This one succeeded before. So here it's build number 17, and if we check the report here, you will find that we have a report, or I have a folder, and inside the folder, you will find that you have a cost report, because Flank is giving you the cost of the devices, because you are using Firebase, you are not you are not in the free tier of the Firebase, because that it's sending you the cost report. You have a JUnit report, which is you can pull it again to your CI server. You have the Android APK, the test APK. You have the matrix, because you are running on Firebase in a matrix. And here you have 2 devices, because we are running on 2 shards in this case. And inside each shard, you can find the logcat, the artifacts, the instrumentation result, the video for the UI test. And this will be the result or the view in a Firebase test lab. So it's based on a matrix, and inside the matrix you have 18 test cases, and on the devices you will find that you had 2 devices or 2 shards. Each shard is including different UI tests. So for example, in shard 1, here you have 9 test cases, and if you go to the shard 2, you will find 9, because previously we had 18 test cases. So here with the Flank, when we are running Flank, so just load the interior log. This was the result. So we build the application for test. We generate the Flank configuration file. Then we run it. So this is the argument that's taking, and now Flank is running on device. So for example, here I have 18 test cases, which give me that will run in 2 shards. So now the matrix is giving me also the matrix URL. So I can just copy and go to the Firebase to check the matrix, and this will be the result. So now we are running and preparing the device, running the test, and at the end you will find that you have a cost. It's not expensive because I'm using a visual device on a Firebase Test Lab, but actually if you are using a physical device, this will be more expensive. So it's give me the report, succeeded, and the matrix, the APK, and you have 18 test bus. And if you have any failed test cases, you will find it here as well. Uploading the smart flank and the result to the bucket, and just it. Now I have another step. If I go to the workflow editor, I have another step. I wanted to pull the result from the bucket to Bitrise again, or to my CI server. So because that I have here a step for collecting the test result. So here I'm using a GC util or GC util command line from GC Cloud just to like copy GC Cloud here. So copy from this path, from the build number, the GUnit report, XML, and also I can pull the video. So for example, I need the video and I need the test result. And if I go back to check the result, how it displayed, so we have already a test report add-on. You just need to send this test cases to the report. So here, maybe we can check together the running UI test. So now it's running, it's run Flink, and it's running now. If we just refresh or back to the test lab, now the matrix is running. But actually, with Firebase Test Lab, you can see what's happening now on the devices. This is, for me, it's like, I think it's need to be a feature in Firebase Test Lab. But for now, we just see it's bending, and you need to wait until all the tests finished and to be able to view the test result. So once we run the test, we pull the artifacts. You can just go to the add-ons, the test report, and because I pull it and I copied it in, I copied it here in this test report. So here you can find the device name, and you can find all the tests. So I just pull the GUnit XML file just to get the result of the test cases. And if you pull the artifact, you can find it in the artifact. So this is the main idea about how we can shard test case. So in case you have 100 test case, 200, you can use Flink. You can add 5, 6 shards, 8, 9 at the end. This will be devices. And you can add, like, change the configuration and just it. So here, and actually this is also only for Firebase Test Lab. So once you have, just to go to the configuration of the Flink, and here you can, for example, I wanted to run in 10 shards. This will split up the, divide the UI test or test suite into different small batches on 10 devices, or based on the number of your UI test. So this a solution. But as we know, you need to wait the devices to be finished. This is one of the, so as we know, each solution has pros and cons. So now we are running on cloud, okay, but you need to wait. So your CI builder will wait until the UI test finish and collect the result and continue with the other steps. So now with the other option, which is a Gradle parallel option, so you can use test shards. This is the same concept, but you can use a Gradle command line. So shards is like refers to, as we mentioned, is splitting up the tests into groups, or roughly like. But this, you are doing it just with a command line. For example, I want shard 2. I want shard something similar to Flink. But just you need to add or use Android test orchestrator for this case. You need to like disable the animation on the device, use the Android test orchestrator, and like this will minimize the shared state crashes, and crashes are isolated as well. So the crashes will be isolated on different devices if you are using an Android test orchestrator. So for example, with a Gradle, you can run this command line with a number of shards equal to, and start with the index 0. So this is the first group, for example. I need to start with the first group of the UI test, and I wanted to run like 2 groups in parallel. Or you can, for example, passing argument like a small size. So you have annotation already with the Gradle. You have a small, medium, a large. You can have, or you can run your like custom annotations. As I mentioned, you can use a regression end-to-end. You can create your custom annotations. But how can I use it? With a CI, you have another option that you can parallelize the builds of the UI test. So let's say you wanted to parallelize the UI test with a local device on the CI server, not local device on your machine. Because now we are running on Firebase, which is the cloud option. But in case your budget is not fitting or not suitable for cloud devices, maybe you don't. Maybe Firebase is expensive for you. So there is another option. But with this option, you need to use the pipelines. Pipelines means that you can run different builds at the same time for running a UI test. So, for example, you have a pipeline. You have stages. For example, I wanted to build the APK first, the APK and test APK, and then I need to share these APKs to different other or sub-builds to start running different groups of the UI test, which will be in different workflows. So we have a pipeline, we have stages, and we have a workflows running on this workflow, on this pipeline. So here we have a pipeline, we have stages. For example, I have a stage 1 and stage 2. And stage 1 contains 3 workflows, for example, and stage 2 contains 2 workflows. The example use cases for this case, that test shard or run barrel emulators. So parallelization here, we have 2 different concepts. You can split up your huge UI tests in different groups or in small groups, which is parallelization or test shards. Or you can run the same group on different devices. So for example, I want to test my UI test on phone or like a mobile or in like any other device. For example, on other, I'm supporting, for example, floatable device, or I'm supporting any other type of device, so I can use it. So you can run in parallel on different emulators or in different devices, or you can sharding the test on different devices at the same time. So for example, how the pipeline is, or how does it work? So let's assume that you have a pipeline, and then you will start the first workflow. The first workflow will clone or SSH the repository, clone the code repository inside the pipeline or inside your CI server, build the APK and test the APK. And once this build succeeded, you will pull the artifacts from the first workflow, and then go to the 2 other workflows or sub-workflows, and in each one, you are specifying that I need to run on a specific device here, and I need to run on other OS version and other device on this workflow. Or here, I need to use a specific group or a specific annotation or a specific package, and here I can use a specific package as well. And once these workflows succeeded, so then you can pull the test artifacts to the pipeline, and then it will be finished. Let's check the other option of run test in parallel workflow. This will not be. This will be only used for the local devices. So. Let me show you first how the pipeline is displayed in the build. So here you can find, here we have 2 options. We have a standalone, which is running only a separate workflow without pipeline. And if you go down, you will find that we have a pipeline, which is running multiple packages at the same time. Or you can have multiple devices at the same time. So if I go to this test, I have here different stages. This is the stages that I was talking about. So, for example, the first stage is a build for UI test. So I need to prepare the APK and test APK first. So I need to, in the first stage, prepare the APK, and then I have another stage. The first one is running on phone, and the second one is running on a floatable device. So if I go to this configuration, and then I will deploy the test result. I will pull the test result from the 2 workflows, and then I will display it on the pipeline. If we go to the workflow editor, here I can find the build for UI test. This including the SSH key, the clone, and Android build for UI test, which is here I'm specifying the app module, the variant name, and at the end I will have 2 APKs. This is the step. And then I will deploy the artifact. With pull artifact, I have another step to pull the artifact from the first stage and to be able to share it with the other workflows. And I have this test for UI test on phone, for example. So I build already the artifact. Then here I need to spinning up the AVD. This step is for initializing the Android device. This will be emulator. So if I open it, sorry, I can find the emulator profile here, the API level, you can describe it, and the OS tag as well. And this is environment variable because you can change it based on the workflow type. So for example, here in the E2E test, or let's go to this one. So this will be the device with this specs. And for phone, this will be the device. So once we have a step for building or like initializing the device, this will be initialized will be initialized two different devices at the same time. Then we are waiting emulator to be initialized. This is about 300 seconds. And then run the Android instrumentation test. The input for this step is taking the application or the APK to install in the device, the test APK, and then you need to specify the Android runner. And here you need to specify the annotation because this is based on Gradle command line. So here you can just mention the annotation. And the annotation also is environment variable. So if I go to this annotation, here I can find that in one workflow, I can run a package with a regression. So in this case, I will run all the regression test cases. And in the another one, I can run the end-to-end test cases. So here I'm using the custom annotation that I created in my project to run on different devices. So in this case, I just wanted to trigger the workflow. So I will start the build, for example, run on multiple devices, and then I will start it. So now I'm started the build manually. So now this is the pipeline and how it's displayed. So all of these stages or workflows are still waiting because it depends on the first one. So we are now building the UI test. So now it's running, and then after that, we will start run both of the workflows at the same time or in parallel. This will take the UI test to run on the phone, and another one will be on another device with another version. And then we will deploy the UI test. For sure, you can access the build details. Here you can find the clone. Now we are building for UI test. We are going to using a Gradle to build the application, giving us the APK and test APK, and then we can continue with the other workflows. Here you can find the artifact, but this will be displayed at the end, and also with details you can find here it's triggered with a different or the specs of the workflow. Until we finish this one, I just wanted to show you also that you can change the machine types. Also, you can, for example, if I go to the workflow editor, here you can find different things. So you can find tab for code signing. So in case if you wanted to complete the full cycle for CI/CD, or from continuous integration to continuous delivery, or maybe you wanted to, or you are targeting continuous deployment, maybe once from the code commit to deploy to the App Store, you can upload your Android KStore file, and this will help you to sign the application or code signing for the application, and this will be ready for deploying the application. For example, let's assume that after we run on Firebase Test Lab, we collect test result, everything is green. So we decided that we will publish the application to Firebase distribution or to the Google Play Store. Once, for example, after the export test results, so now I'm confident about everything. So I can click on this plus button, and I can search about, for example, Firebase. With the Firebase, I have here a step for Firebase app distribution. So just you can select it, and here you need to add the Firebase token. You need to add the app path. It already will be taken from the previous one, the Android builder for UI test. And the Firebase app ID. And you can add the release note, the max length, everything about the testers, the names, everything related to Firebase, and this will take your APK and send it to Firebase. In case this Firebase is OK or no problem, so you can search about Google Play Store, you will find a step as well for uploading the application to the Play Store. That's also you need to add the service account, the JSON file. For sure, I'm adding it in the secrets, so you can search about secrets. I think I don't have it here. No, this is a service account JSON file, and the package name of the application. The application bus will be taken from the environment variable, and the track. For example, here I can upload it to alpha, beta track, and user friction, status, everything, and it will be deployed automatically to your account on the Google Play Store. In case you need to add anything, here you can find all the tips that related to like testing, releasing, committing on Jira, a ticket, and everything. So just you need to search about your step. So now it's finished already, and this one started already and finished, and we are still running on the floatable device. And then after that, we will find. So if we just go to these workflows, here you can find that the step for Android instrumentation, we already run the UI test, and we don't have issue or problem with the UI test. And this one finished as well. And if we open the Android instrumentation, you will find also it's running the end-to-end test, and this running a regression and the smoke, because here we are adding like a package or the test runner. So this is mainly about how can we parallelize UI test. So here you have a different options. You have a pros and cons. But in this solution, you are only using the virtual devices because it's only emulators, because it's a CI on cloud, and you can connect for sure a physical device. But with Firebase Test Lab, the cloud device, you have two options. You have a physical device and a virtual device, but physical device will be expensive. So you need to choose which one is suitable for you. So this is like a solution for your a local, not local, but your with your CI server or within your server. But with Firebase, you can use different options. For sure, you can use any other option like browser stack or Sauce Lab, for example. But the parallelization or the idea behind the Flink or the Firebase is a sharding. This is only between a Firebase and the Flink. So this was the idea about parallelize UI test on a scale. And just the last thing, that's a conclusion about the sharding your test can be a great way to boost speed. So sharding as a concept or parallelize UI test is like great way to boost the speed of your test. And with using hardware in cloud, it typically only makes sense to a very large number of your test cases. But in case you don't have a large number of your test cases, you can run the normal Firebase Test Lab. So for example, I have also one step just I wanted to show you that we have already a virtual device or the step for Firebase that you can search about virtual device. And this will take your APK and test APK and send it to Firebase without any Google credentials. It's integrated internally inside or with Bitrise and the Firebase Test Lab. Okay, so maybe the internet is not. Oh, anyway, if someone wants to like more demo, so we have already both outside, but I will try it again. Just try to maybe load it, but anyway, so I can demonstrate it outside if you'd like to learn more about it. So it's. At the end, you will be able to test more frequently and respond to new issues. You can integrate a UI test in early stages. You can fail fast because you are integrated already UI test like a gate check on your CI server. Now you are not merging any code with issues, and you are fixing or fetching the issues on the early stages on the development before releasing your mobile apps. And once you deploy the application, so it's not about also UI testing. So maybe once you release your application, maybe you can add additional layer about monitoring your application. For example, using a Firebase Crashlytics, for example. So this will monitor your application after releasing it to the production. These are the resources. So Flink is on GitHub, and also these are like articles about like using or parallelization of UI test. And thank you.
Okay, very welcome.